let us look at the corrections of the test that we wrote. Right. Question 1, it had to do with general question. As I always indicated that you need to know your theory. The first question, they wanted you to define Newton laws. Now, Newton's second law simply says, like I said, it is the extension of Newton's first law. An object will remain at rest not unless the external force act on it. That would be Newton's first law. Then in stating Newton's second law, you then have to say and. An object will take the direction of the applied force. For 2 marks, this is what you were supposed to have stated. For simple 2 marks, an object will remain at the rest. Right, an object will remain at rest, not unless the external force act on it. An external force act on it. Then, that's what you are supposed to have said. And then an object will take the direction of the applied force. For 2 marks, this is what you are supposed to have stated. Then the second question, they wanted you to define bending moment. Bending moment at any section of a beam is the algebraic sum of the moment about the section of all the forces to the left or right of the section. That would be your bending moment. Now, even if you have stated your bending moment as force multiplied by perpendicular distance, right, you were still going to get full marks because you would have stated it as per the formula. You would have stated it as per formula. But what did you do? I don't know. What did you do? I don't know, honestly. And these are simple definitions that you need to know. Like I said, that our theory is worth 18 marks, and we can't afford to lose that 18 marks, good people. We need to know our theory. Right. At any section of a beam is the section of a beam is the algebraic sum of the moments about the section of all the forces to the left or right of the section. Another way of stating bending moment, you would have stated it as per the law of moment. Sum of the clockwise forces equals to sum of the anti-clockwise forces. Left and the right there, they simply indicate forces acting on the left hand side and forces acting on the right hand side as per those sections. Right. That's what you were supposed to have stated. Now, angular displacement. Angular displacement, like I said, you can define it as per the displacement. I mean, it is easy. It is the change of position. It's a change of position of an object on on a secular course. On a secular course. This is how you're supposed to have defined your angular displacement. Change of position of an object on a secular course. Like I said, that the angular indicates for you that it is motion taking place on the secular course. If you are defining linear displacement, you would have, stated it as the change of position from point A to point B on a straight line. I mean, this definition and the linear definition and the angular, it is one the same thing. The difference it's on the secular course. Then defining the linear velocity, it is the rate of change it is the rate of change of what it is the rate of change of displacement. It is the rate of change of displacement in relation to what? In relation to time. 2 marks. This is how you are supposed to have stated your velocity. Torque, good people, torque, turning force. Turning force, 2 marks for defining it that way. Torque is a turning force, or is the tendency of a force to rotate an object about an axis, pivot, or fulcrum. I mean, it simply means it's a turning force. For 2 marks, stating that torque is a turning force. Now, question 1, it worth how many marks? 2, 4, 6, 8, 10. 10 marks. I mean, you were supposed to have collected this 10 mark, good people. 10 marks for free. 10 marks for free. What did you do, Mina Aya Zisterek? 10 marks for free. What did you do, Mina Aya Zisterek? Ten marks for free for stating those simple definitions. Now let's look at question 2. Let's look at question 2. Now, on question 2, we are given a statement. We know that if we are given the statement, more especially when we are dealing with kinematic, we then have to convert the given statement into a vector. Then a vector diagram will indicate for us which method to use in solving the magnitude of the vector and the direction of the vector. Now let's look at the given statement. On the given statement, we are given a river flows in a southeasterly. Now, like I've said to you, that easterly simply means it is the direction from east to west. Now, if it is the southeasterly direction, that means it's generating from the fourth quad going to the second quad. Now, that is the first thing that you were supposed to do. Convert the given statement into the vector diagram. This is north, this is east, south, west. Now, a river flows in a southeasterly. Southeasterly, we know that it is flowing from to that direction. At what speed? Okay. While a boat crosses the river in a southerly direction. Now, the southerly direction, it is the direction from south to north. Then you make your second Cartesian plate. This is north, east, south, west. It's going where? North. Right. In ideal circumstances, the boat sails at a velocity. Now, the boat, it is sailing at 8. This would be the southerly, it is the direction of the boat. It is 8 meters per second. Then that of the river, it is 5.6 meters per second. Now, the second thing that you need to do after you have projected this, you apply parallelogram. Parallelogram says two sides must be the same and equal. We'll be applying parallelogram and tail to tail and head to head method so as to establish the position of what? Of the resultant. All right. Two sides must be the same and equal. This side must be the same and equal with that one. This side must be the same and equal with that one. Now I'm having head to head. It means the opposite. It is true. It is tail to tail. It means this is where my resultant would be. Then I will denote this as my A, B, C. Now this alternates with that angle. It means I'm having 45 and this one it is what? It is 90. It means that angle 90, the angle that I need to use, it is 90 plus 45 equals to 135 degrees. Okay. Now, by the look of things, this diagram, it's an oblique triangle. Since well, it's an oblique triangle, we'll then be using the cosine rule. It is b squared equals to a squared plus c squared minus 2ac cos beta. Now my a, this is my a, it is opposite to that vector. It means it is 8 squared plus 5.6 squared minus 2 times 8 times 5.6 multiplied by cos 135. All square root. Then I get my answer for that as 12,598 meters per second. If you've used the cosine rule, this is how you were supposed to have done your cosine rule. Then the second thing that we need to determine, it is the direction. What is it that we know in determining the direction? We said it that when coming to direction, we always calculate the angle of where we have started projecting. And this is the angle that we need to calculate. That means we are calculating the peak A. Now, in calculating the peak A, we will be using the sine rule. It will be sine A over A equals to sine B over B. Then our peak A would be the inverse of sine, open bracket, A, sine B over, then the inverse of sine would be A, it is 8 multiplied by sine 135 divided by 12.598. Then I get my answer in calculating that as 26,681 degrees. Now, let's check this. The resultant, remember from this vector to west, it is 45. Now, the resultant occurred on the other 45 degree. Remember, I said it that whenever we deal with our resultant and the projection of our vector diagram, we always work from the 90 perspective because our quads are made up of what? Of 90 degrees. Now, our resultant has occurred within the other 45. This is our resultant. Now, that which we've managed to determine, it is this angle, 26,681. We then have to apply, we then have to say 26,45 minus 26,681. Then we get our answer as 18,32 degrees. Right. Now, the 18,32 degrees, it is from north to where the resultant is. It is 18,32 degrees. Then we have to then apply that principle, the given principle. You always start with the cardinal closest to the vector first, then the angle of deviation, then the other cardinal point. Now, in this case, you can tell that your resultant, it is close to north, because from north to where the resultant is, the angle of deviation, it is 18,32 degrees. Unlike when you start from west to where the resultant is, it will be west 45 degrees plus 26,861 degrees. Right. But either way, whether you state it, you make west the point of reference or north, it doesn't matter. But we always use the given principles. The principle says you start with the cardinal closest to your vector first. And in this case, it is north. It will be north 18,32 degrees west. Or the fact that it has occurred within the second quad, and those and the quads are made up of 90. You can make worst your reference point, then it will be worst. If you make worst your reference point, it will be worst. Let's add the two. It will be 45 plus 26. 45 plus 26 comma 681 degrees, then it gives us what, 71 degrees. Then it will be worst 71 comma, what happened now? Let's cancel this. 71 681 degrees north. Whether you indicate your direction as west as your reference point or as north your reference point, it doesn't matter. You will still get the same and the correct answer. Now, in stating everything, it will be resultant equals to 12,598 meters per second at east 18 north, I mean to say, not east, north. Right, it will be north 18 degrees, 18,32 degrees west. Right, then this question is worth how many marks? 4 marks. This is what you are supposed to have done. Then question 2.1.2. Let's look at question 2.1.2. Let me wipe this diagram here anyway. Right. Now, in determining 2.1, they want us to calculate the time taken. In calculating the time taken, you are supposed to use this formula. V equals to S over T. What is it that we are looking for? We are looking for T. We make T the subject of the formula. It will be S over V. Right. Let's wipe. Now, we are given the displacement. We are given the displacement as 1,200. That means it was going to be 1,200 divided by our V. We've calculated our V there. It is 12,598. Then this is your meter. This would be meters per second. The meter and the meter will cancel out. Then you'll be left with 95,253 seconds. This is how you were supposed to have tackled question 2.1.2. Easy marks, 6 marks. What did you do, Mina Ayazi Sterek? Now let's look at question 2.2. All right, on question 2.2, we are as well given the statement. We then have to convert the given statement into a vector diagram. Now, before I continue, those who used the vector method, let's apply the vector method. Let's apply the vector method in solving these problems. Let's apply the vector method. Right, so let's apply the vector method before I continue. Right. In applying the vector method, we said it that we write everything on the same Cartesian plate. We write everything on the same Cartesian plate. This is north, that's your 90. This is east, it's your 0 degrees. West, it is 180 degrees. South, it is 270 degrees. Then east, 360 degrees, the revolution, it is completed. We said it that the river it is the river it is flowing southeasterly. That means it is heading that direction. Southeasterly, that is the river. At what speed? The river at 5.6 meters per second. Then the boat crosses the river in a southerly direction. We said it that it is going where? North. At what speed? 8 meters per second. Now, the vector method, you are determining the vertical component and the horizontal component. We know that the vertical component, it is made up of sine, and the horizontal component, it is made up of cos. Now, what is it that we are looking for? We are looking for the vector and its position. We always start at 0 and looking for those vectors and their position. Now, when we start at 0, we are looking for vectors. Boom, we found our first vector. It is 8. The position would be sine 90 plus. Then we start all over again from 0, looking for the second one. 190, boom, 45. Right. The magnitude of that vector, it is 5.6. The position, it is sine 90 plus 45, it is 135. Right. If you've used this method, then in calculating the horizontal component, we'll write everything as it is. Where the sine, we put what? We put cos. It will be 8. Where the sine, we put what? We put cos. It will be cos 90 plus 5.6. Where the sine, we put what? Cos 135. Then in calculating our vertical component, we get our answer as 11,959 meters per second. And our horizontal component, we get it as negative 3,959 meters per second. Then in calculating the resultant, it will be the resultant equals to the VC squared plus the HC squared, all square root. You apply the Pythagoras method. Then it will be 11,959 squared plus 3,959 squared, all square root. Then I get my answer as 12, the answer must be the same, 12,597 meters per second. Now, if you've used this method, this is what you were supposed to get as your answer. Now, in determining the direction, we said it that the coefficients of your vertical component and your horizontal component will indicate for you the position of what? Of your resultant. In this case, you can tell that we are having a positive vertical component. It means it is heading where? North. Because all forces going north, they are positive. Now your vertical component there, it is 11,959. Then your horizontal component, it is negative. It means it is heading where? West. All forces going west, they are negative. It is 3,959. It means your resultant lies on the second quad. Whether you determine alpha or theta, it doesn't matter. You will still apply the given principle. You start with the cardinal closest to the vector first. Now, in this case, I will determine alpha. In determining that, we will be using tan alpha equals to horizontal component over vertical component. Our horizontal component, then it will be the inverse of tan 3,959 divided by 11,959. Then I get my answer as 18,32 degrees. Now, this angle here, it is 18,32 degrees. Now, you can tell that your resultant, it is close to north. Then it will be north 18 degrees, 18,32 degrees west. Or you can say west as your reference point. It is 71 comma, as we've calculated, 71 comma, we said it is 71 comma 9 something. Yeah. Okay, I do it. Oh, it is 71 comma 681 north. Right. Now, whether you've used the vector or the cosine, your answer was supposed to be the same and the correct one. Okay, I will post the rest of the corrections now. Thank you, good people.